Hey, what's going on, guys? Welcome to my Simplifying Radicals activity. Um, this is for my MTCH 8030 class for the summer of 2022. This will also be a video that I will post on on my school website in order for to help my students out. So if any of my students are watching this, hey, awesome. So basically, this activity that we're dealing with deals with simplifying radicals out, and it's essentially a way for us to use manipulatives, maybe not manipulatives, but to use more like kind of physical medium for students to kind of like visually see how they can simplify radicals out. Because a lot of times, we do radicals, just kind of on pen and paper. Um, and so kind of I feel like giving them that ability to kind of physically work with simplifying the numbers and variables out. I think will maybe will help them out a little bit. Okay, so basically materials, like what will you need for materials? So like I'll talk about both basically like students are going to need whiteboards and kind of a piece of paper to write down their work, and they're going to need to cut out cards of numbers and variables. What does that look like? Well, let's go back to, so I'm going to go back, and I actually have it pulled up, not there, sometimes this, but right here. So basically what I would do before class, before we would do this in a class, is I would actually print out copies upon copies of this printout right here. And essentially these, you'd cut these apart. You would have 5 cards of 2s, 5 cards of 3s, 5 cards of 5s, 5 cards of 7s, and then you get into your variables, 5 cards of x's, y's, and z's, okay? Now, for the sake of this activity, I'm just sticking with 5 of everything. You could go more than that. You could go 6 of everything, 7 of everything. You could have 7 x's, 7 y's. You could have more variables. Just for kind of uniformity's sake, I'm just sticking with 5 x's and 5 y's for that. Okay. So let's go back to the materials here. So that's basically what it is. So I'm going to kind of demonstrate, kind of model what I would expect from my students, kind of show them like, hey, this is kind of show like I was showing my students, okay, hey, this is kind of how I want you to do your things here. And I'm going to kind of model that, using I'm going to kind of pretend like I'm using, the cards and whatnot, while drawing. Just an FYI, this is going to more than likely be a 2-part video. I will have the links to both of those in the discussion board as well as on the website as well. Alright, so we're moving. So not exactly, I don't have like a list of steps that I'm going to give, to my students for this, but basically let's start from the ground. Let's start from the base examples and work our way up on how we should do this. So basically what I'm going to do here, so as I said, my students, and because of the recording program I can only use the color red for this, so I'm going to use red. Sorry if anybody doesn't like it. In fact, I'm going to move it to purple. There you go, another darker purple. Okay, so let's just pretend like this space down here is my whiteboard space. Okay, this little red line right here, and this right here is going to be my whiteboard space. So this is basically what a student would be writing here. Okay, so basically on their whiteboard they're going to draw in a very, very large square root sign, very large enough to fit in, those squares that I was showing you. Okay, and essentially what they're going to do is they're going to, first of all, with this base example, they're going to create these numbers using those prime numbers. Now, how do we do that? Well, you find 2 cards with numbers on them that multiply to this number right here. So, for example, we have we have 2s, 3s, 5s, and 7s. And I have 5 of each. 5 of each of those, okay? And I could pick 2 from the same one. So this first example here, 49. Well, I know that straight up, the 7 right here, alright? I could put 2 7s underneath my square root sign right there, all right, because 7 times 7, all right. Now, what we're looking for here underneath the square root sign is we're looking for any pairs of cards, essentially, all right. And if I look here, I have a pair of 7s, all right. I have 2 7s. I'm looking of 2 of a card, all right. I have 2 7s here. So basically what that means is if I have a pair of cards right here, I can essentially bring that to the outside of my square root as one single one. So basically what this tells me is that if I have the pair of 7s, I can bring that to the outside. It's not written very well here, but I can bring that to the, and on their separate piece of paper, they would write out square root 7, square root 7, go outside, just create 7. All right, two 7s inside creates a 7 on the outside. Okay. What that tells us is that the square root of 49 is just equal to 7. Okay. Let's work that other example. Let's work that other example out here. All right. So if we had 36, okay. Well, I don't really exactly have a six card here, but what I could do is I could create using these 3s and these 2s here. So, because as I know, I take 2 3s, 3 times 3 times 3 is 9, and then I can take 2 2s. See, this part right here is the one thing I'm going to tell my students you're going to have to do a little bit of experimenting with, all right? You're going to have to kind of play around with these cards, see which ones multiply, all right? Because as we see, again, if we plug all of these numbers in, 3 times 3 times 3, 3 times 3 times 2 times 2, that's going to equal 36, okay? And just as I saw as I was looking for in my first example, I'm looking for these pairs, okay? And we're looking for those pairs. So on their separate sheet of paper, students will write out 3 underneath the square root, 3, 2, 2. A pair of 3 means that I have a 3 on the outside. A pair of 2s means I have a 2 on the outside. You multiply those two. If you have now multiple numbers on the outside, instead of having just one pair, we have 2 pairs now, which means we're going to have 2 numbers on the outside. All I do is just multiply those numbers together to get 6. So what that tells me, is that the square root of 36 is equal to 6. That makes sense because 6 times 6 gets us 36. Okay. Now let's do another one here. All right, actually, I'm going to change up the square root symbol so I have a little bit more room to write down here. Let's go by right there. Okay, so we have the square root of 75, and we need to make this number using these cards right here. All right. So, and again, as my student, and again, if you're a student, you kind of have to play around with the cards. See what kind of experiment. What number? How can I use these numbers to multiply to 75? And if you look, well, 75 can be broken up as 25 times 3. Okay, so we already know we're going to use 1 3. And 25 is not exactly a number that is in my list over here, but I see that a number in my list, 5, goes into 25, and not only that, 5 times 5. So from that, I can put inside of my square root on my whiteboard, I put 2 5 cards and a 3 card. And now what I'm doing, once again, as I did for these 2 up here, I'm looking for pairs of numbers. And as I look, I have a pair of 5s right here. On my separate sheet of paper, what I could do is I write out pair of 5s. 2 5s on the inside makes 1 5 on the outside. Now, something a little bit new. What do we do with this 3 that remains on the inside? Well, we have to have 2 of them in order to bring this 3 on the outside. But if we just have 1, well, that just remains on the inside. I mean, imagine, you can only imagine this square root as a prison. You can only break out of prison if you have a partner. You can't break out of prison by yourself. Not exactly the best, metaphor in the world, but But yeah, so this 3, because there's only one, stays inside of the square root, and we can just write it as 5 with a square root of 3 right here. Okay, so the 2 5s on the outside, in the inside, makes 1 5 on the outside. 3 on the inside makes 1 3 on the inside here. All right. So let's do that last example here. So let's break this 12 up here. All right. I know so simplest one I can do is, let's go 2 times 6. Well, I have a single 2 card, but I don't have a 6 card. But I know that I can do 3 times 2 to get 6. So I add another 2 and another 3 card in there. All right, so I have a 2 card, I have two 2 cards, and a 3 card. All right, that's how I broke up my square root of 12. I'll write in 5 square root of 3 right here. Square root of 12 right here. All right. I'm looking for my pairs of numbers. All right, I see that I got a pair of 2's right here. And I only have the 1 3 right there. So again, just like we were talking about, the 2 here has a partner. He can break out of the house, break out of the prison, whatever you want to call this. 2 2's on the inside makes 1 2 on the outside. This 3, he's by himself. He can't escape, so he has to remain inside of the square root there. Alright. So again, that's basically kind of our creating the numbers from basically creating any numbers from, these prime numbers here. So let's do a couple more examples here. And I'll write out the numbers that we can choose from over here. And again, then we have 5 of each. So do 45. So let's think of numbers that'll multiply to 45. Instantly I think of 3 and 15. So I do 3. But 15's not on my list here. However, I know that 15 can be broken down even further as 3 times 5. So we had 3 times 15, and then 15 turned into 3 times 5. Once again, I'm looking for my pair of numbers. And as I look, I have my pairs of 3's right here. I have 1, 2, 3's. So one pair of 3 on the inside brings that 3 on the outside, brings that 3 to the outside. So I'm going to have 3 on the outside. This 5 on the inside, there's only one of them. It can't escape. So that 5 remains on the inside there. Try to keep these all up here. All right. Let's go with the square root of 18. We have our square root. Let's think of 18. I'll go 2 times 9. All right, 2 times 9. So I'm going to put a 2 card down there. I don't have a 9 card, but I know that 3 times 3 gets me 9 as well. So I'm going to put 3, 2, 3 cards down. So under my square root, again, this is all on my whiteboard, I have 1 square root with a 2 card underneath and 2 3 cards underneath. Alright? I circle the pair of 3's. 1 pair of 3 brings 1 3 on the outside. So I have 3. I only have 1 square root of 2, 1 2 underneath there. So that 2 has to remain underneath the square root there. And then finally for the 27, we draw our big square root on our whiteboard. We look at our cards. We think of what numbers multiply to 27. Off the top of my head, I get 3 times 9. So 3. And then we have 9, but we know that 9 is 3 times 3 again, so we can put 2 more 3 cards down on our whiteboard. So we do 3 times 3 times 3. And then we have our pair. We bring that pair to the outside, 3, but we have 1 3 remaining. Now this will happen sometimes. Maybe sometimes you'll have 3 numbers on the inside, 1 2 3. You can only pick 2 of them to make a 3 on the outside. We have 1 kind of left over here. Again, we're looking in pairs of 2, not pairs of 3, not pairs of 4, just